All right, guys, so I'm going to make a video for those of you who have not been here over the past few days, or if you are needing some extra help. Some of the stuff we've been doing is confusing, getting overwhelmed. I just wanted to make a quick video kind of recapping the material from this week so far. So the first thing we talked about corresponding parts of congruent figures are congruent. That was on Monday. And you can also say corresponding parts of congruent triangles are congruent. And it's often abbreviated as CPCFC or CPCTC. Okay. That was what we talked about Monday. And we did work out of your book. So this started on page 139 in your book. So let's just go through this and kind of recap what we talked about. So what this means, CPCFC or CPCTC, is if you are given a congruency statement, kind of like this says triangle ABC is congruent to triangle DEF. If you are given that statement, what that entails is each side, each angle, everything is congruent. And you can come up with 6 statements about those corresponding parts. Okay? And we will do that in a moment. Okay, so here, let's identify what a corresponding part is. Something I like to do, I like to stack the letters on top of each other. So when we're talking about triangle RGK, and that's supposed to be congruent to triangle QB, what this does, this allows me to see what angle is corresponding with what other angle and what side is corresponding with what other side. So our first statement says RG is congruent to MQ. And then so segment GK is congruent to what? Well, GK is here, so that's got to be segment QB. Okay. And then the last statement here would be RK is congruent to MB. Okay. They're in the same position, and this works for sides as well as angles. So again, I'm going to make my little cheat sheet. Stack the letters on top of each other. Angle R corresponds with angle M. Angle G corresponds with angle Q. So those two are congruent. And then angle K corresponds with angle B. All right. So if you had this, and the book goes into a lot of detail, but I'm just going to make a picture here and write out your 6 statements. If you know that triangle ABC is congruent to triangle DEF, you can come up with 6 congruence statements about the segments and angles. Okay, so let's just write those triangles. I'm going to cheat my way here because this is a much better triangle that I can draw. So we have that triangle, and let's do another triangle. Actually, I'm going to move it over. All right. So the first triangle is ABC. So let's label those vertexes A, B, C. And the next one is DEF. Okay, so basically you have to come up with 3 congruent sides and 3 congruent angles. Okay, so again, ABC, I'm going to use the same colors I used. Hold on. We have triangle ABC, And then you have triangle DEF. Okay, so segment AB should be here, is congruent to segment DE. Right. Then if you go in that order, BC is congruent to EF. And then lastly, we have AC is congruent to DF. If you want to say CA and FD, you can. Okay, forgot to do that. Now, those take care of the sides. Now, you need to label your corresponding angles. So we have angle A is congruent to angle D. Do you see how they line up? Angle A is congruent to angle D. And then next, angle B is congruent to angle E. That looks bad. Let me rewrite that so you can see that. Angle B is congruent to angle E. So B would be here, E is there. Right. And next, lastly, you have angle C is congruent to angle F. Okay, I know there's a lot going on here, but in short, if you are given this kind of statement, ABC, triangle ABC is congruent to triangle DEF. All of the corresponding parts, all of the corresponding angles and sides are going to be the same. So when you're given that statement, you can come up with 6 different congruent statements. Okay, and sometimes you're going to be given algebra, sometimes you're not. So for this example, it's just asking you to find the measure of angle B. Well, if you do my trick, ABC, stack it over DEF, B corresponds with E. E happens to be 65 degrees. So then therefore, B is 65 degrees. And that is all this says. B is congruent to E. The measure of angle B equals the measure of angle E. The measure of angle E is 65. So the measure of angle B is 65. Okay. This one, it doesn't give you that congruent statement. So like triangle ABC is congruent to triangle DEF. If it doesn't say that, you cannot assume that the corresponding parts are congruent. Okay? So this would be no. And because you're not given the congruent statement. Okay, so here we have triangle STU is congruent to triangle VWX. So again, stack those on top of each other. And it's asking you to find, on number 4, it's asking you to find SU. SU is here. In my little chart, S and U corresponds with V and X. V and X, that side is 43 feet. So SU is 43 feet. Okay. Next, it's asking you to find the measure of angle S. Okay, angle S is here. Angle S corresponds with angle V if you look at my little chart. So angle V is 38 degrees. Therefore, angle S is 38 degrees. Okay. Sometimes you're going to have to solve some equations. It's going to give you expressions, and you have to set those expressions equal to each other. Okay, so triangle ABC is congruent to triangle DEF. And on this part, it's asking you to find AB. Where is AB? Be this side. Okay. And AB corresponds with DE. Okay. So you have 3x plus 8 and 5x. Okay. If AB and DE are congruent, you can set these two expressions equal to each other and solve for x. So you have 3x plus 8 equals 5x. Okay, the first thing you're going to do is subtract 3x on both sides. So that gives you 8 equals 2x, and then you're going to divide by 2. You get 4 equals x. Okay. Now, you found x, you have to still find what AB equals. Remember, AB is represented by this expression, 3x plus 8. You know x is 4, so just plug in the 4. So that's going to be 3 times 4 plus 8. 3 times 4 is 12. 12 plus 8 is 20. Okay. And sometimes you're going to be looking at angle measures as well. So on this example, we're trying to find the measure of angle D. Again, do my little trick. ABC is congruent to DEF. Trying to find the measure of angle D. Angle D corresponds with angle A. Okay, so angle D would be here, which is 6y plus 2. Okay, and then angle A is here. Remember, it's got the little degree symbol, so that's how you know it's representing a degree. And that was 5y plus 11. So you're going to set those two expressions equal to each other. Okay, first thing I'll do here is subtract 5y. 6y minus 5y is just y, plus 2 equals 11. And you're going to subtract 2, subtract 2. We get y equals 11 minus 2, which is 9. Okay, so now you can plug in that 9 to figure out the measure of angle D. Again, the measure of angle D is represented by 6y plus 2. So you plug in, so 6 times 9 plus 2, and that gives you 54 plus 2, which is 56. Okay. So that's kind of a recap of what we did Monday. Sometimes you have quadrilaterals, it's the same process. That was your homework for Monday. The past 2 days, so yesterday and today, I'm recording this on Wednesday, so Tuesday and Wednesday, we started looking at these. Okay, these are also ways to prove that triangles are congruent to each other. And if you'll notice, you have 5. Those 5 are side, 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 angle, side, angle, side, angle, 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 side, and HL. HL is only for right triangles. All right, and we do not have an angle, 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 and you do not have side, side angle. Okay, those don't happen. So when you have an included included angle A here would be the included angle. That just means it's the angle in between those two sides. So we have side B and side C. The angle in between would be angle A. This is going to work out with side, angle, side. Right. You also have included sides. So this is going to be the side that's in between two angles, and this is going to work for angle, side, angle, because that side is in between. Here we practiced labeling the included angles and the included sides. So on the diagram, number 1, it says we have to find the included angle between the pair of sides given the sides are MR and TM. So MR is here. TM is there. So the included angle that's in between those two sides would just be angle M. Right? And then when we get to 2 and 3, you have to be very careful when you're labeling these. So you're given side RT, and you're also given side MR. Okay. So we want this angle. Okay. And R is the vertex of several different angles. You can see it can represent this entire angle. It can be the one we're looking for, which is here, or R can also represent this angle. So you have to be specific when you're labeling these. So I'm going to label this one as angle MRT. You could also do angle TRM. Okay. So next you are given side TQ, and then you're given side RT. Okay. And you want to find the angle in between those two sides. That would be this angle. Okay, and again, you have to be specific when you're naming these. So you can call this RTQ or you can call it QTR. I like QTR, so we're going to call this angle QTR. All right. Next, you had to use the diagram and name the included sides. So if we have angle TRM, TRM is going to be this angle. And angle RTM, RTM is this angle. So the side that's in between those would be side RT or segment RT. Okay, next you have angle TQR. TQR is going to be here. And then you have angle QTR, QTR, which would be here. The side that is in between those is TQ or segment TQ. All right. Then number 6, you had to label the in-between side. In between the following two angles, you had TMR, TMR, and then you had the angle RTM. So the side that's in between those would be just MT or TM. Right. So, and this just goes over the different definitions. So when you have side, 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 you're going to have 3 congruent sides. One side there, 2 sides here, and then third side is there. Okay, I'm going to change this so you can see it a little bit better. Okay, so side MN, you have to go in that order, would be congruent to side QR. And then NP is congruent to RS. PM is congruent to side SQ. So that means triangle MNP, go in that order, is congruent to triangle QRS. Okay. Next is side angle side. So here we are given a side, an angle, and another side. Side, angle, another side. And it's important to notice that the angle is in between the two sides. That's why it is side angle side. Okay, so PQ is congruent to WX. And those are segments. Angle Q is congruent to angle X. And finally, side or segment QS is congruent to segment XY. So therefore, triangle PQS, go in that order, PQS would be WXY. XY. Okay, next is angle side angle, ASA for short. So we are given an angle, given a side in between, and then the other angle. Okay, and it's angle side angle because that side is in between. It's the included side. Okay, so angle A is congruent to angle D. Segment AC is congruent to segment DF. And then finally, angle C is congruent to angle F. So go in that same order, triangle ABC is congruent to triangle DEF. All right. Angle, angle, side. This is when you have two angles and a non-included side of one triangle. So if you'll notice, you have an angle, you have another angle, and then you have a side. The side is not in between, okay? So angle A is congruent to angle D. Angle C is congruent to angle F. And segment BC, or side BC, is congruent to side EF. So triangle ABC is congruent to triangle DEF. Okay. And lastly, you have hypotenuse leg, and hypotenuse leg only works for a right triangle. Okay, it only works for a right triangle. And you have to be given the hypotenuse. First off, what is the hypotenuse? The hypotenuse is the longest side of the right triangle, and it's directly across from your right angle. Okay, so there would be your hypotenuse on that triangle. So the hypotenuse for the first triangle, well, let's look at the sides first. That's what it gives you first. So the leg BC is congruent to the other leg EF. Okay, and then the hypotenuse would be AC on the first triangle, and then it's going to be DF on the second. Okay, so you only need two components in order for it to be hypotenuse leg. You need the hypotenuse and one of the legs, and it has to be a right triangle. So triangle ABC is congruent to triangle DEF. Okay, so here we just have some examples of what you're going to see when you practice this. And you just have to look at these very carefully, look at what it gives you, look at the position of the angles and the sides. So on the first one, you're given a side, you're given an angle that's in between, and then you're given another side. So this is just going to be side, angle, side. Okay. On B, we're given a side, another side, and another side. So this is just side, side, side. Okay, on C, you're given two angles on a side, right? Angle, another angle, then a side. So for this one, do you notice that the angle is not in between those, sorry, the side is not in between those two angles, okay? That would be angle, side, angle. But because it's the non-included side, it's just angle, angle, side. Over here on D, you are given, let's look at the first triangle, angle, another angle, and then you're given this angle, but the side is different. Do you see how in this triangle, the side is in between those two angles? And the side in between these two angles would be here. That would make it angle, side, angle, but that's not the side it gives you. It gives you the one that's up here. Okay, so these would actually be not congruent. Okay. E. This is going to be hypotenuse leg because it is a right triangle. This little indicator tells you it's a right angle, it's a right triangle. And the hypotenuse would be this part because it's directly across from the right angle. And it gives you another leg. So this would be hypotenuse leg. And then F, we have an angle, then you have a side, then you have another angle. So that is just angle, side, angle, because the side is in between those two angles. Okay, sometimes you're going to have to fill in some missing information. So the stuff we've just done, these examples, everything was given to you. It's nice. You don't have to mark anything. But sometimes you're not going to be given that much information. If you have a midpoint, so for example, if you have a triangle and it says, let's say point B, that's your midpoint. That means this side and this side are congruent. Or if you had a bisector that cuts lines in half and that cuts angles in half. So you have to know to mark that when you get to that kind of thing. Sometimes they share a side. So on this example, where I put that purple X, that is where they would share a side. So if we were given that these two angles are the same up here, we could say, nope, just kidding, never mind. Forget I did that. If you were given this angle right here is 90 degrees on both of these, you can say these two triangles are congruent from side, angle, side. Okay. Sometimes you're going to be given this bow tie situation. Basically, something like that. That's going to create vertical angles. Also, you're going to have parallel lines, and those create a bunch of different types of angles. So just watch out for those. I will try to guide you in the right direction on those kind of questions. Okay, so I'm going to pick some. So like these. Here we have a shared side. That shared side happens to be in the middle of two angles. So this one would be congruent through angle, side, angle. Over here, again, they share a side. These two triangles would be congruent through side, side, side. On this one, it gives you that bow tie kind of question. So you have vertical angles you have to fill in. And this would actually be side, angle, side. On this one, it tells you WZ bisects angle XYZ. So XZY. So this angle is congruent to this angle. Okay, and it also bisects XWY. That means these angles are congruent as well. So what you're given here is two angles that are congruent and they share a side. So that's going to be angle, side, angle. And let's look at this one. Actually, we can look at both of these. So this has a shared side and it's a right triangle. Both of these are right triangles, but we need more information. So we're only given a side and one angle. So this would be not congruent because we don't have enough information. Okay. This is your midpoint. So that means we have congruent segments here and here. So we are, if you look at that, that's going to be angle, angle, side. Angle, angle, side. Okay. One more page. Sorry, this is taking forever, but it's 2 days, actually 3 days worth of information. So here, if this side is 90, you can assume that the other side's also 90. They share a side. So these two triangles would be congruent through side, angle, side. All right. Well, let's be careful on this one. This part's 90 if the other side's 90, and they share a side. But so if you notice on this one, they did not give you the hypotenuse, right? That's why we said side, angle, side. On the next one, they give you the hypotenuse because that side is the one that's directly across from the 90-degree angle. So this one is actually going to be hypotenuse leg because the leg would be the shared side and here would be your hypotenuse. Okay, I'm going to do one more. We're going to skip the last one. Notice that these two triangles are kind of overlapping. They kind of make a crown and they share this side. So they have a congruent side over here. They have congruent angles there and then a side. So this would be congruent through side, angle, side. All right, and we are not going to do this one. We did not do this one in class. And I hope this helps. If you're ever out, please check Canvas for more videos. I try to upload them as I see fit. And some people are struggling with this material. So that's why I decided to make this video. Have a great day.